So recall that a solution is made by taking a solute and dissolving it into a solvent. So a classic example is taking some salt and dissolving it in a glass of water. The salt would be your solute and the water would be your solvent. And what you create is a solution of salt water. So concentration is simply a measure of the amount of solute inside of a solution. So concentration of that glass of salt water would be a measure of how much salt you have dissolved in that water. The unit that we use to measure concentration is referred to as molarity. And molarity is often abbreviated with a capital M. And a lot of times we say molar when we're describing the concentration or the molarity of a solution. The formula for molarity is the number of moles of the solute divided by the liters of the solution. So you got to know how much solute you're dissolving, and you have to know the volume of the entire solution to calculate molarity. So we're going to take a look at some example problems. Here in number 1, we take 3.54 grams of potassium nitrate and we dissolve it in water. The solution is brought to a volume of 500 milliliters. Calculate the molarity of the solution. So the first thing I'm going to do is record our molarity formula. Molarity, remember, is moles of the solute over the liters of solution. So let's first deal with the moles. Let's insert the number of moles of solute. What is being dissolved? We're dissolving 3.54 grams of potassium nitrate. Well, that unit right now is in grams. I can't put grams into this molarity equation. I have to put moles into this equation. So my first task would be to take these 3.54 grams of potassium nitrate and let's convert that into moles of potassium nitrate. So off here to the side, I'll take those 3.54 grams of KNO3, do a little dimensional analysis. We're going to convert this into moles of KNO3. We know that 1 mole of potassium nitrate is going to be equal to the mass of 1 potassium, 1 nitrogen, 3 oxygens, all added together, and I'm going to be looking at that periodic table for the masses of each one of those elements. So I calculate the molar mass, and I get a molar mass of 101.11 grams KNO3. So we're going to get an answer of 0.03501 moles of potassium nitrate. So that's exactly what we're going to plug in here into our molarity equation, 0.03501 moles of KNO3. Okay, done with the numerator. Now for the denominator. We need to put the liters of the solution in the denominator. So I find the liters, or something about volume. The volume here is 500 milliliters. So again, I have to follow the molarity equation exactly as is written. I am not allowed to put in any unit other than liters into that denominator. So again, off to the side here, let's go ahead and convert those 500 milliliters into liters. And recall, 1 liter is equal to 1,000 milliliters. And so that's going to be 0.500 liters of solution. So 0.500 liters of solution goes in the denominator. You plug this into the calculator and you're going to get an answer of 0.0700 as your numerical answer. And so the unit would be moles divided by liters, MOL over liters, or more commonly, you're going to see, instead of writing moles divided by liters, chemists, we typically take this entire moles over liters and we write it as a capital M instead. Okay, so you can either leave it as MOL, mole over liter, or you can replace that part with this capital M, and we're all saying the same thing. That capital M just really means moles over liters.